All right, so this big packet is restriction enzyme cleavage of DNA. I'm collecting this for a test grade. We're not having an actual test on chapter 15. It's only one chapter, so I'm going to collect this and put it in for a test grade. So it's actually a really easy way to improve your grade. So it's all self-contained in here, so if it doesn't make sense with me explaining it, maybe if you read it along with me explaining it, it will make more sense. But we are going to take different pieces of DNA that have been chopped up using restriction enzymes, so things that we've been talking about before, and then we're going to put them on a gel, and then we're going to have this so that it is, then we can measure these. And so this is a little bit time consuming, but it shouldn't be too difficult. So down here, there's a little chart, and so it says distance traveled in base pair length, distance traveled base pair length, distance traveled base pair length. So our sort of standard that we're going to use is the hind 3. So we're going to use this one right here. And so what you need to do is you need to get a ruler, and you'll go from this well where we would take like a little pipette and we'd squirt it in there, and then we'd turn on the electricity and they would travel down. So these pieces are really small. This piece is sort of a big blob, and then these are sort of in the middle. And so on here, there's a couple of notes before we get started on what actually to do. So this is for this ideal gel, assume that these two bands appear as a single band instead of resolving into separate bands. So these two, 27,491 and 23,130, are going to be this single band. So they didn't separate, and that's for a few reasons. Maybe we didn't let it run long enough. Maybe the gel wasn't the right kind of gel. So there's a few reasons why that might happen. So when you're measuring these, we're going to give the same distance for these two as this one smudge on there, that one little where that segment of DNA dropped. And then it says these bands, so it's these two down here, 564 and 125. These bands do not appear on the ideal gel and will likely not be seen. So we're going to have 1, 2, 3, 4, 5, 6, 7. So it's 1, 2, 3, 4, 5, 6, 7, and then these two aren't on there. So what I want you to do is, taking your ruler, measure from here to the front of the gel, from here to the front of the gel, from here to the front of the gel. So we'll have a distance here, and we'll put it here and here for that, and then we'll have a distance from here to this one, and then we'll put it in the next one, from here to this 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 one. And so then we'll have numbers, and then we'll have distance traveled and base pair length. And so then you're going to take those two numbers, and you're going to have distance traveled and base pair length, and you're going to plot those, and then you're going to draw a line of best fit. And then you're going to go to the other two, BAM-H1 and ECO-R1, and you're going to measure, and then you're going to have a distance traveled, and then you're going to take that distance traveled, and then you're going to go here, and you're going to, on your line of best fit, go across and figure out what your base pair length is. So then you're going to use distance to determine base pair length on that line of best fit that you made from here. And so you're going to do that a couple of times. So then you're going to answer these questions. You can use Google if it helps you, but you might be able to figure it out. And so there's several pages of questions, talks about drawings and things. So when I grade this, what I'm going to look for is that this table is completely filled out, that all of your questions are answered, and that your graph is drawn with one line of best fit. So hopefully that makes sense.